In this last lesson, in the first section, we're going to look at a few of the different things that we can do with our formal language. What are the kinds of things that having a formal language around might be good for? Now, you might have a database of music or a database of something else. A music player database is the kind of thing that a lot of us have got experience with. And one thing that often happens when you've got a big collection of things is that you might want to extract information from your database. One thing in a music player is the idea of a smart playlist, where you specify, I want to collect together some tracks which satisfy different criteria. Now, your music player might allow you to construct a playlist on the basis of rules like these. Match any of the following rules, and here I've got two little rules. One says, give me all of the tracks which are by Keith Jarrett and have 5 stars, and the other rule is, give me all of the tracks which aren't by Keith Jarrett but are still jazz tracks. This describes a criterion that a track has to satisfy if it's going to be collected by this smart playlist. And if you've done a bit of thinking about logic, you can see that there are some little logical concepts that are here, hidden inside that any, and that all, and that artist is or artist isn't. We can specify this in a formal language. We can consider a language which is made up of atoms like these. Keith Jarrett, which is an atom which might describe a given track and might be true if the track that we're thinking about is by him, and false otherwise. Or 5 stars, and it might be true if it picks out a 5-star track, and false if it picks out a track that I haven't rated as 5 stars. Or jazz, which will pick out the jazz tracks and will be false of the things which aren't jazz tracks. Then the smart playlist, which says match either of these two rules, and each of the rules then say match both of the following criteria, can be understood as saying give me all of the things which are Keith Jarrett and 5 stars, or not Keith Jarrett and jazz. And so we've got a different way of describing the kinds of things that we could do to query a database. And now we might ask the question, are all of the different things that you can describe in this formal language the kinds of things that you could make a smart playlist for? And it turns out that that's not obvious, that's not straightforward, using the different criteria in building a playlist in different kinds of databases that you might have. But this connects up the idea of querying a database and the different kinds of ways that we can describe things in a formal language. Formal languages can't just describe the forms of everyday statements that you or I might make in our natural languages. They also describe the way that we might inquire of information from large databases. So that's one example of how we might use formalization. Another example comes from natural languages. And we've already seen this. Natural languages are highly ambiguous. One source of ambiguity in natural language is what we call scope. And one of the advantages of formalizing sentences in the language of propositional logic is that scope ambiguities can be identified and resolved. So, for example, I might say, Clancy ate quickly and went to work. That's ambiguous between saying that Clancy quickly ate and then Clancy went to work, but she didn't do that quickly. So she quickly ate and she went to work. Or we might say Clancy quickly did these two things. She ate and went to work. The sentence in English, Clancy quickly ate and went to work, is ambiguous between those two things. Similarly, Madison might say, I'll have fish and chips or salad. Again, that's ambiguous. Is Madison saying that she'll have fish and chips or she'll have salad? Or is she saying she'll have fish and either chips or salad? Again, this is an ambiguity in scope. Is the and the dominant connective, or is the or the dominant connective? Last example, we've already seen something like this. If it rains, I'll get wet unless I'm lucky. Is this an if statement which says, if it rains, here's what happens, I'll get wet unless I'm lucky? Or is this an unless statement which says, if it rains, I'll get wet unless I'm lucky? These are all scope ambiguities. Now, how do we use natural language and formal language to resolve these? Well, consider what it is that Madison wants when she says, I'll have fish and chips or salad. We can make very explicit the kind of ambiguity by translating this, formalizing it in the two different ways. We could consider what it is that Madison wants by saying it's fish and chips, or it's salad, or we could say it's fish and it's chips or salad. There's no ambiguity in the formal language. These are two very different formulas. Whereas this is one sentence of English. Now in English, often we can distinguish these two different readings by means of pauses or commas. We could say, I'll have fish and chips or salad. Or we could say, I'll have fish and either chips or salad. We've got ways of resolving these things, but a very precise way of resolving these things is to try translating it into a formal language. There's no ambiguity in this formal language, so any way of translating it is going to need to resolve this scope ambiguity. So I want you to have a look at another example. Select which of these options are possible translations of the sentence that's here on your screen. How did you go? Did you think that there was only one way of translating that sentence, or is there more? And does that give you an insight into the kind of ambiguity that there is in the natural language? So what we've seen is that the formal language is very, very different from the natural language that we speak, in the sense that the formal language is precise and our natural language is ambiguous. This is both a virtue and a vice. It's something which is positive and negative. It's negative because it's not very much like the language that we speak, but this has got a benefit because translating into it means that we need to make different kinds of choices. So having a formal language in mind gives us a way of identifying the kinds of structures that might be there, which are different ways of representing information, where choosing one sentence mightn't actually force us to choose, and we might actually not have to make a difficult decision. Do I mean this or do I mean this? If you translate it into a formal language, that forces you to decide which of those two options you might be needing to say. And that will at least give you some helpful information, which might then be useful in reasoning or in understanding what it is that you've said. So what we've done is we've introduced the formal language. What we're going to do in the next section is interpret it. And Jen is going to introduce the notion of a truth table and ways of interpreting the language that we have.